All right, the next section is on using systems of equations to solve application problems. Now here we've got just a set of things to do, steps to use. First, you want to read the problem. Read through it. You want to look and see, okay, what are they asking us to find? So you want to know that right away. What are you trying to find? And then look, what did they tell you? What was given to you in the problem? Once you've done that, then you choose your variables. So if you can see two things, you choose your two variables and write down what they represent so you remember at the end of the problem. Well, x represents this, y represents this. Then set up your equations. If you have two variables, you should have two equations, three variables, three equations, etc. And then solve using one of the methods, so substitution, elimination, graphing, one of those two. And when you find one of the variables, substitute that back in to one of your equations and find the other variable. Now you have different types of problems. The first one is called number problems. Your number problems, and I think a lot of this you're translating. You're translating words into math. So if number problems convert each sentence into an equation, replacing words with math symbols. So like this one, find two numbers whose sum is 34 and whose difference is 10. So we pick our two numbers. So let's say we let x be the larger and let y be the smaller. It doesn't matter what you use, what letters, you just need to know what each one represents. So now it says their sum is 34. Well, sum means add. So it'd be x plus y is 34, is means equals 34. So we converted that first part, their sum is 34, we converted that to math. X plus y equals 34. Then the other equation, or the other part, says whose difference is 10. Well, difference means subtract. Since x is the larger, let's take x minus y. So there's the difference of two numbers, is equals 10. So there's our two equations right there. That's the first thing you want to do. Well, now we need to solve that. Well, this one looks like a pretty easy one to do by elimination. Let's say, because notice we have a positive y and a negative y. So what if we just add these two together? So I'm going to put this x plus y equals 34 underneath those, so it'll be easy to add. X plus x is 2x. Negative y plus y is 0 equals 44. Divide by 2, x equals 22. Now take that and plug it into one of the two equations. Let's say we plug it into this one. That'd be 22 plus y equals 34. If we subtract 22 from both sides, y equals 12. Now to check and see if that works, let's plug those two answers into the other equation. Well, here that'd be 22 minus 12 equals 10. 10 equals 10, so it checks out. So our two numbers are 22 and 12. That's what you do for a numbers equation. Some other possible ones. Money problems. Like if you have a bunch of coins in a jar, they tell you like the denominations of the coins, say how many nickels, how many dimes make this much money. Usually you have one equation that's the total number of coins. The other equation is your value of each one of them, so that's how to match your total amount of money in your pocket. You have admission problems. So it'll say you have these two types of tickets. How many of each do you sell to make this much money? Well, you make one equation for the total number of tickets sold. And then make a second equation that's the total amount of money collected. And then solve those. You have time, distance, and rate problems. Hopefully you've seen the equation before. Rate times time equals distance. Very, very common equation to use. Rate times time equals distance, or time equals distance divided by rate if you solve for time. You have current or wind problems. You have to remember, like, let's say you're in a boat on a river. Well, you have how fast your boat would move if you were in still water, so no current. That's one rate, and the rate of the current. So if you're going with the current, your rate would be R plus C, your rate in still water plus the current because it's pushing you. If you're going against the current, so upstream, it'd be R minus C because the current's against you. Or if you're in the air, you have your your airspeed, which is like how fast you set the plane to go, and then you have the wind, which would either be pushing you or pushing back in your face. So if you were going with the wind, it'd be R plus W, because the wind is pushing you. If you're against the wind, it'd be R minus W. Then you have mixture problems. They'll tell you you have the percent of this and is this percent whatever, this percent coffee, this percent coffee. Usually you make one equation, which is the total volume you have, and you make a second equation knowing how much of the substance you're looking for. Then you have investment problems. Usually they'll tell you have this much money to spend. You could invest part of it at this rate and part of it this rate. How much at each rate to end up with this amount of money. So usually you have one equation, which is the total amount of money you have to invest, and you have a second equation, which is the dollars of each. Tried to put in some examples of each of these. So you have, like here, this first one is an investment problem. So here we have $12,000 to invest. We have two funds. One pays 5%, one pays 3%. We want to make $500 a year. How much is invested at each rate? So first, how much at each one? Well, let's say X is the amount at 5%, and Y equals the amount at 3%. So first, for your total, well, if we have X and Y, that means X plus Y, our total amount has to be $12,000 that we invested. Now, for how much money you earned at each. Well, at X, we make 5%, so the amount of money we earn is 0.05 X. The amount we earn at Y is 0.03 Y. So you take the percent times the amount at that percent. So 0.05 X, 0.03 Y, and it says the total we want to make is $500. There's our two equations. Now we need to solve that. Well, if we solve that by elimination, we want either the X or Y to cancel out. Let's say I wanted to get rid of Y. What if I multiplied this top equation by a negative 0.03? So this would be a negative 0.03X minus 0.03Y, and 0.03 times 1200 is a negative 360. So if we combine those, 0.05x minus 0.03x is 0.02x. The y's cancel. 500 minus 360 is 140. So if I divide by 0.02, x is $7,000. Well, if I plug that into the first one, 7,000 plus y equals 12,000. So y equals 5,000. So it'd be $7,000 at 5% and $5,000 at 3%. That's how you do an investment problem. This break-even problem. So here, you're in business, you're starting a business, you want to make a new soft drink. So you invest $10,000 in equipment. Each bottle costs you 65 cents a piece to produce, and you sell it for $1.20. We want to know how many bottles do you have to spend to break even? So it says how many bottles, so let's let X be the number of bottles. Let's let Y be our break-even point. Now we want to make two equations. One for our costs. Well, our cost, well, we initially spent $10,000 plus it costs us 65 cents a piece for each of our X bottles. Then the money we make, so our income, we make $1.20 for each bottle. So $1.20 so our break-even point is where these two things are equal. So this is really like substitution. We take 10,000 plus 0.65x equals 1.20x. There's our equation. These are a little different than the other ones because you could really do this with, essentially, it's a one variable problem. It's kind of a new problem. I haven't seen these much, but I see it, so I thought we'd do one like it. Now we need to solve for x. So if we subtract 0.65, we get 10,000. 1.20 minus 65 is 0.55x. If we divide by 0.55, we get 18,182. It actually works out to a decimal, but approximately that many. If I take 10,000, divided it by 0.55, I get 18,181.8. So I just rounded it up to 82. Well, that's not dollars, sorry. That's that many bottles. If we sell that many bottles, that's our break-even point. Right? The next one is a time, distance, and rate problem. We have an airplane. It's flying into the wind and against the wind. So let's let R be the rate in still air, or that's called the airspeed. Let's let W be the rate of the wind. Always a good idea when you start to write these things down, so you have them in front of you. So that means when we're with the wind, there's good, so it's R plus W. Against the wind, so the wind's in our face, it's R minus W. So, into the headwind, it travels 2,000 miles in 4 hours and 24 minutes. Now remember on these, we're going to use rate times time equals distance. So rate into the wind is R minus W times our time. 4 hours and 24 minutes, that's 4 plus 24 divided by 60. So rate times time equals our distance, which is 2,000 miles. Then against the wind, that's against the wind. With the wind, well now, if we're coming back, let's assume the wind's blowing the same direction. So with the wind, it's R plus W. Now it only takes us 4 hours to go that same distance, 2,000 miles. So this is the equation for against the wind. R minus W, so that's our rate times our time equals our distance. This is with the wind, so that's the rate with the wind, R plus W. Only took 4 hours to go the same 2,000 miles. Now if we take that second equation, 4 plus 24 divided by 60 is like 4.4. So if we multiply that out, that would be 4.4R minus 4.4W equals 2,000. And this one would be 4R plus 4W equals 2,000. So those are our two equations. Now, we would like to cancel out one of the variables. Well, here, think of the cross multiply thing. Here I have a negative W and a positive W. So let's take this top equation by 4. So that's like the cross multiply part. That would be 17.6R minus 17.6W equals 8,000. Now let's take the second equation times 4.4. That'd be 17.6R plus 17.6W equals 8,800. So we cross multiply because now notice my W's will cancel out. So if we add, that'd be 35.2R equals 16,800. So do we divide? With our calculator, we take 16,800 divided by 35.2. I get 477.27. So let's say we round that off to 477.3. So R equals 477.3 miles per hour. Now if we take that and plug it in, let's say we plug it in here. So we take 4 times 477.3 plus 4W equals 2,000. So if I take 2,000 minus 4 times 477 times 3, oops, sorry. $2,000 minus parentheses 4 times 477.3. Doing the wrong thing. You get 90.8. So the wind is 90.8 miles per hour. For some reason that seems off. All right, now admission problem. We had a total attendance of 1175. We have adult tickets and children tickets. So let's say we say A equals the adult tickets and C equals the children's tickets. So now our equations, the total attendance is 1175. So that means adult tickets plus children's tickets equals 1175. The adult tickets are $15 a piece. So we make $15 for every adult ticket, so that's 15A. The children's tickets are $12 a piece, so 12 for each children's tickets. And our total we make is $16,275. So we have one equation for our total tickets and one for the money made. So 15 a piece for each adult, 12 a piece for each child, total of $16,275. So again, if we do this by elimination, let's see, if I take this top equation times a negative 12 to make the C's match, that'll be a negative 12A minus 12C. If I take 1175 times 12, I get 14,100. So a negative 14,100. Now I can add these two together so that the C's cancel. 15 minus 12 is 3A. 16,275 minus 14,100 looks like 2,175. Divide by 3 equals 725. If I plug that into the first one, 725 plus C equals 1175. If we subtract 725, looks like 450. So 725 adult tickets and 450 children. Or a mixture problem. She's going to mix two types of alcohol. She's got some 2% alcohol and some 7% alcohol. We want to see how much of each she should use to end up with 100 mils of 5% alcohol. So let's say we let X be the 5%, X be the 2% and Y be the 7%. So that's how many milliliters of each one. So the total wants to be 100. So X plus Y equals 100. That's just the total volume. Now, how much alcohol we have? Well, if we have X of the alcohol and it's 2% each, then the amount of alcohol that is 0.02X. The Y is 7% alcohol, so plus 0.07Y. The final amount of alcohol, it's going to be a 5% solution, and there's 100 ml. So basically we're saying how much total alcohol we have. So there's our two equations. If I multiply this out, 0.05 times 100 is just 5. So now if we want to do elimination again, let's say we multiply this equation by a negative 0.02. So if we do that, we have a negative 0.02x minus 0.02y equals a negative 2. If we add those two together, the x's cancel. I get 0.05y equals 3. If you divide by 0.05, you get y equals 60. So that's 60 milliliters of 7%. If the total was 100, that would be 40 mil of 2%. And the last one is a money problem. So in his change jar, Tyrell has 32 coins, $5. If all of his coins are either nickels or quarters, how many of each coin does he have? Let's say we let N be the number of nickels and Q be the number of quarters. You could use X and Y if you want. I like to use a variable that matches when I can. He has 32 coins. So that means the number of nickels plus the number of quarters equals 32. If you're just doing the number of coins, you don't care how much each is worth. It's just the number of coins. Now the second one, we use how much they were worth. Well, each nickel is worth 5 cents, so 0.05 times the number of nickels. Each quarter is worth 25 cents, so 0.25 times the number of quarters. Because if you had like 3 nickels, that'd be 15 cents. If you had 4 quarters, that'd be $1. And that total amount is $5. There's our two equations. Now again, if we use the elimination method, we take this top one times a negative 0.05. That'd be a negative 0.05 times the number of nickels minus 0.05 times the number of quarters, and 0.05 times 32 is what? Negative 1.6. Now combine those, the ends cancel out, the quarters, 0.25 minus 0.05 is 0.2 quarters equals 3.4. So if I divide by 0.2, Q equals 17 quarters. Well, if you had a total of 32 coins, the other 15 must be nickels. You check that out, 17 quarters, that'd be what, $4.25? 15 nickels would be 75 cents, so it does work out to $5. So there's some examples of application problems.